This is Conway's Game of Life. Well, it's not really a game, so how do you play it? You set up an initial configuration on a 2D board and watch the cells evolve. It's a zero-player cellular automaton invented in the 1970s by a British guy named John Horton Conway. Here are the rules of this game. Imagine an infinite 2D board. Each cell is alive or dead and updates every tick based on the following. A cell that has 2 or 3 neighbors lives on. A living cell that has less than 2 or more than 3 neighbors is squished to death. A dead cell that has exactly 3 neighbors, they have a little fun and it gets born. That's it. 3 simple rules, yet from randomness you get still lives, oscillators, gliders, and even this glider gun that breeds glider forever. They're having way too much fun. And just by these rules, the Game of Life is Turing complete, meaning that given enough memory it can compute anything computable. So I wrote it, but in a shitty language that I made. Let's see how I suffer. So first thing first, let me introduce my language. It's called BASIC. It's a general programming language written in Python, and it compiles to Linux x86-64 assembly. I made this language just for my final project, and in the end I thought I would need a cool program to demo the language. So like any normal human being, I chose to write the Game of Life. That's pretty normal, right? Right? No? Okay. At the time I was writing it, the language supports the following. Specifically, I want to talk about variables. You know, I didn't have time to implement a type system, so my language supports only one type, 64-bit integer. That's it. To get different types like 8-bit integer, you would have to do some bit magic. So in some sense, my language is more difficult to use than C. It is pretty useless, I ain't gonna lie. But programmers, man, we make problems for ourselves and solve the problem. That's how we do. So let's see how I did it. Spoiler alert, I'm going to encounter many problems, so I'm putting a problem counter here. So first step, I want to represent the game board using a 2D array. And just like that, I encountered my first problem. My language doesn't support 2D array. What a great start, but that's completely fine. 2D array in the memory is actually just a normal 1D array. When you access the indices by specifying the row and column number in a privileged language such as C, the compiler will simply do the math for you. But I'm not privileged, so I'll just do them myself. So I'm going to define row and column equals 10, and create an array with size row times column times 2. Why times 2, you ask? That's a very good question, because we're actually maintaining 2 generations of board, one's the current and the other is the next. Or else every cell's next state would be dependent from the current generation, and that's not what we want. After that, we can initialize the board with some random ones. So we encounter the second problem. How are we going to achieve random within a very limited budget? Well, we can't, so thanks for watching. Just kidding. I have a system called interface in my language, and there is a system call named sysgeRandom. It obtains series of random bytes from dev-urandom and put them in the memory address you provided. To do that in my language, I will need to allocate 8 bytes using malloc, which was actually broken but I didn't know. For every cell, I can call the getRandom system call to get 8 random bytes. And since my language treats everything as 64-bit integer, I can just mod the number by 2 to get 0 or 1. Next thing would be first print the cell and updating every cell based on their neighbor count. I'll maintain the iteration count, and during even iteration, I'll need to calculate on the first board and modify the second board. For odd iteration, it would be the opposite. And then I can count the neighbors using this bit of code. Basically iterating through the neighbor indexes using 2 while loops, and because my language has no AND or operator, I have to instead use the bitwise logical operator to determine some logic. Finally, I'll set the future board depending on the neighbor count. Oh, and don't forget to print a new line. Let's run and see. Segmentation fault. Very classic. But if you watch closely, you will see that the cells actually lives for a while, but the updating rate is too fast, so we couldn't see the action. As for the seg fault, I think I'm gonna just ignore that for now. For the updating rate problem, we can just use a slower computer. Just kidding. Once again, I'll solve this using a system call, particularly a nanosleep system call, which is basically sleep in C but with higher precision. But we'll encounter a new problem. The system call takes 2 arguments, both of them are structured. And if you paid attention to my video, you will know that my language doesn't have that. So this is the end, right? No Game of Life in my language? Nope, of course not. Structures are just ones and zeros after all. Accessing the field of a structure is just reading some bytes offsetting from the start of the structure. So what I can do is allocate a variable with the size of the structure, which again the malloc doesn't actually work, I'm just being very lucky here. Offsetting from the structure and then the reference and set the value. And we want to set the first field to 0 and the second field to 100 million in order to sleep for 0.1 second. For the second argument, we can just pass in no because it doesn't matter. And boom, a normal looking game of life. If I want a bigger board, I can just change the row and column variable. Isn't this great? No, this fucking sucks. I want it to be automatically sized to the terminal size. But how can I do this though? Without the help of some fancy standard library, surely there's no way to get terminal size, right? After all, my language is still not capable of my desired game of life, and my mom will be disappointed in me. And once again, Linux system call saves the day. There is a system call named IO control that can get the current terminal width and height for me. Again, I can allocate a structure using the broken malloc I have and just set the row and column value in the structure. But one more thing, I'm limiting array size to this value, just in case someone has a massive terminal and that would break the program because of the stack memory limit. And ta-da! Conway's Game of Life in my awkward programming language. That's cool, right? What? You don't think that's cool? But this thing compiles to exist. No? Still no? Alright, man. Okay, bye.